Okay, so this is the first of our labs dealing with Civil 3D or AutoCAD. So one of the first things, we're still going to be using the DaVinci ArcGIS drive space, so the Z drive, but now you're going to be creating Civil 3D lab folders. So for this first one, go ahead and start and find the Civil 3D Lab 1 folder and make a copy and put it in your own personal folder again. And then you're going to want to start Civil 3D. So if you, depending on whether you're using your own computer or Apps Anywhere or the lab computers, it might look a little bit differently. Autodesk, the company that makes AutoCAD and Civil 3D, does provide student licenses that you can download onto your personal computer. So even sort of separate from Apps Anywhere, the software has always been available free to students. But I'm just going to go and look. So Autodesk, like I said, is the company that creates AutoCAD, and they actually make a lot of different products as well. But when you go to the Start menu or the the pull-up menu, yours might look slightly different than this, but there's a couple of things I want to point out. So there's two different programs. One is AutoCAD, right? And AutoCAD programs are always going to be shown with this red A. And AutoCAD is meant for sort of digital drafting. So here, this is just plain AutoCAD. I can see the red A over here. And then the other one that we're going to be concerned with in this class is Civil 3D. And so Civil 3D has some additional design features, not some, a lot of additional design features for tasks that are common to the civil engineering profession. So it's sort of like Civil 3D does everything that AutoCAD does, plus more. And then the way our lab computers are set up, there's usually two different icons. One for if you're starting a drawing in imperial units or US or customary units, or if you're starting a drawing in metric. So in most cases, you're always going to be wanting to start this imperial. This just sets up the drawing for the units that you want and kind of does all the proper defaults. With that said, you can certainly open a metric drawing in Imperial. There's nothing different about these programs other than some of the default setups. So if you happen to be in Imperial and you open up a drawing that is in metric, it sees that those units are set and it kind of overrides that. So anyway, I have Civil 3D open here, and you can see, a lot of the things look the same, but then there's some additional, this tool space is, I'm going to get rid of this, but this tool space and this prospector menu, this is really the big difference between when you're in the Civil 3D environment versus the AutoCAD environment. And so it happens inevitably, some students will get into it and go, where's my prospector menu? We're going to be using this tab quite a lot in our labs. And if you just see that they're not showing up, double check to make sure. See, it says Civil 3D with the blue versus the red, and make sure you're in the right one. And generally, because there's so many different ways of getting into the AutoCAD environment, you typically don't want to double click on a drawing file or a DWG file because it'll kind of open up in an environment that you're not expecting. So go ahead and always open up the Civil 3D Imperial, and then from there you can go and open up your drawing here. There's also a start menu where you can start with a blank drawings, open files, and it also will show you the latest drawings that you've had open. Okay, so I'm going to go ahead and close this AutoCAD because I just prefer to always be in Autodesk, or the Civil 3D, just because it has more functionality. But I'm going to expand this, and so at this point you should have Civil 3D open, and you should have navigated and opened up your Lab 1 drawing. This Lab 1 drawing we're not going to be sort of working on it. Some later labs we're going to be doing some more with this, but for this lab it's just sort of showing some of the things that we're going to be doing and using this to as a demonstration to show some of the different menus and whatnot in Civil 3D. So what we're looking at is a plan view. So we're looking down at a subdivision that has a road coming in and a circular road, and each of these purple lines are showing a housing development lot. So these are places that builders or private people could be buying to build a house. And then it has some contours, and then here these are the profile views, and kind of throughout the next several labs you'll sort of get familiar with working with all of those. So one of the things that's challenging about Civil 3D is just the pure amount of commands and windows. And so I think using other software, you're pretty familiar with seeing, these types of ribbons up at the top. That as you click on them, they show up. But you'll also notice that we have this whole tool space or prospector menu over here on the left. There's some additional tabs at the bottom. There's a toolbar at the bottom. There's toolbars at the side. And then there's all these kind of navigation ones. So the other thing that's challenging is that sometimes we have what's called context-sensitive menus. So that the menus up here, these ones on the end, change depending on what type of object you have selected. So in this case I selected something and this additional parcel segment menu came up. But if I deselect it, those menus go away. And so sometimes you sort of struggle with where commands are, and it's just because you haven't selected the appropriate kind of object first. So, but through the next labs that starts to become a little bit easier. You get kind of used to it. So I showed you this earlier, that there are tabs so you can have multiple drawings open. You'll get the asterisks if a drawing hasn't been saved, if there's been some work on it that hasn't been saved. Now, if some of you might have been working in the sort of competitor to AutoCAD, which is MicroStation, and their version of Civil 3D, which is there's two, GeoPack or En-ROADS. And one of the things that's a little bit different is in MicroStation things are saved automatically. You can still undo, but they're as soon as you make a change, your drawing is updated. AutoCAD is the opposite, that you have to save before changes to be sort of written to the hard drive. So take special care to make sure that you are saving and think about that asterisk. So the benefit of it is you can kind of test something out and see how a design change will look, and if you don't like it, you can always just exit without saving, and it just reverts back to where you were at the beginning of the session. The next part, we'll just kind of walk through some of the main menu areas that we're going to be using in the next couple labs. So at the top, what's called the application menu. This looks like a lot of software, like Microsoft products, where you can start new and save and all of that. For the most part, you tend not to really use these type of commands. You would kind of go to here, to the start menu, to navigate to a new one, but it is available if you are used to that. But I do want to point out this one up here that says Civil 3D. You can change your the whole sort of menu configuration depending on what you're doing. So if I put it into drafting and annotation, essentially what this does is, even though I'm in Civil 3D, it makes it look like AutoCAD. For the most part, don't mess with this. You want it to say Civil 3D, but I just point that out in case you ever are wondering where some of your menus have gone. You've verified that you are in Civil 3D, but it doesn't look like Civil 3D. You might have inadvertently changed that up there. There are, and then up here is just your regular sort of tabs, what we call tabs, ribbons, and panels. So you can tab along. These brings up the particular ribbon, and then when we talk about a panel, so if I'm saying the annotate ribbon in the dimension panel, it means looking for particular commands in here. Most of these have little down arrows, which means that there's additional commands. So there's the default icon and then additional icons on the bottom. So I won't go through all of these. There's in the handout part of the lab, it kind of talks about them. But in general, we kind of use this home in most places, and this create design is going to be pretty important for starting with Lab 2. We're going to kind of go through each of these things that we need to define, and then drawing if we just want to draw basic objects or modify them. So, and then the last part is kind of the layers, where we draw things on multiple layers. And layer convention is very much defined either by the company you work for or the agency that you're submitting your drawings to, so they'll usually have defined ones. But this is the default that Civil 3D does. And so in certain cases you can kind of tell what it's talking about. So this is a property, a boundary, property line, there's the bearing of the property line, there's annotation and all that. But learning your naming convention and making sure that as you draw objects you put them on the appropriate layers, something that when you go to work they'll spend a lot of time with you on. But anyway, this is where you can turn layers on and off. Sometimes you want to limit what you're looking at so that you can see things easier. And anyway, like I said, through the next labs we'll kind of get to familiar with a lot of these. The last ones, we won't spend as much time on, but the survey tab is where you bring in survey data and manage the points and all that. So at the bottom of the screen there's always, it can move around, but it tends to, unless you've moved it, it tends to be down here. It's a command line. So almost all commands you can either get to multiple ways. You can select an icon, so this one would be to draw a line, or I could type, line down here, or I start to type and it can tell me, oh, there's lots of things that have the word line in it, but if I wanted to just draw a line, it would be a single. And so I think as you get more efficient at working in Civil 3D, you start to use the command line more and the icons less, because it's just faster. And then there's even shortcuts. So I could type in L for line instead of having to type the whole thing out, and it puts me in that line command. So the other part over here is a lot of navigations. These ones are what are called transparent commands, meaning that you can use the command in the middle of another command. So for basic navigation, you have your wheel of your mouse. If I change the wheel in and out, that's where I'm going to get some. If I push the wheel down, right, and I hold the wheel down, I get my pan window, and I can do that. I can also physically, hit the icon and get the pan window. But I think it's pretty convenient to use the wheel to zoom in and out and to pan in. And you'll be able to do that in the middle of commands as well. But you have these transparent commands, and then you also have some navigation. So sometimes we can do things where it looks like we're no longer looking down at our drawing, and so you always want to check up here. And make sure that your north arrow is pointing up, and it's like you're looking at the top of the box. But if I were to start switching around with this wheel, I can start rotating the drawing. Sometimes it takes these commands can be kind of large, and I can start changing the. Okay, an easier way to kind of navigate the view that you're seeing is to go to the View menu. And if you look over here on the views, if I put it to top, that's kind of the default view, and it goes back and it puts me back where north, and I'm looking at the top. But I could look at my drawing from the bottom, so this would be like I was in the center of the earth looking out. So it looks like a mirror. I can look at things from the left. Sometimes these commands take a little bit of time. So this is like a slice where I'm looking into, I can see my road and some of the topography. Right. And you can, like I said, rotate these things around using your menu, but often you just want to verify that you're in the actual view that you think you are. So kind of with north up and top down. But anyway, this view, you can zoom different extents and you can rotate your views back. You can also change what you're looking at. Sometimes this gets changed in the middle of commands and or inadvertently getting hit. in most cases, most of the labs we're going to be doing, you're going to be seeing things in this 2D wireframe. But if you change them, depending on what type of objects you have, there might not be too much difference between them. But anyway, if things start to look a little strange, you might check what visual style you have on. So I'm going to make sure I'm back to north, top, and I'm in 2D wireframe view. Okay, so over here is this tool space menu, and it has some different ones: prospector, settings, survey. This prospector tab on the toolbox is something that we'll be going back to throughout the next labs. And so this is where we store what we're going to call our Civil 3D objects. So what's powerful about Civil 3D over AutoCAD is that it recognizes certain things or certain objects that we use in the civil engineering profession. And it stores them. And so in addition to it knowing where it is located in space, it also collects attributes, and we can sort of run design features on it. So the reason we're starting with this drawing 1 is that this is a drawing that has lots of Civil 3D objects already created. By the end of kind of the next couple labs, you're going to see how these things get created, and you're going to create your own and start working on your own projects. But anyway, so to access information about these Civil 3D objects is this prospector. The settings looks pretty similar, so sometimes it's easy to get confused about which one you're in, but this just actually says what attributes, the settings, like what's going to get stored, what units, and all that. So really you want to be in the prospector menu, which is talking about what objects are in this drawing. So you'll see over here that there's a lot of plus signs. So let's go to surfaces. So surfaces are our three-dimensional representations of the ground. And we have kind of two different surface icons. This first one is just EG, which is existing ground. We can do a lot with our sort of basins and watersheds and define watersheds in them. But this, we just kind of want to look at sort of existing ground alignments. So this could be our road alignments or pipe alignments or transmission line alignments. I have different kinds. You can see I could have rail alignments, my curb returns. So these are the corners of your curbs, those radii in there. There's miscellaneous alignments. They could be rivers. But center line alignments are usually the center of your road. Can be the center of pipes and whatnot, but these are the center lines of roads, and we see we have two. We have First Street and Second Street, so we have one road that is defined along here, and then another one along the center. If I want to actually know where where this particular one is, I could say zoom to that, and so I can see that, oh, okay, that's First Street, and if I zoom to this one, I see that that's Second Street. Okay, I'm going to shut up these ones and my points, kind of compress them back down, and I want to look at sites. And it's when I click on it, if I didn't have any sites defined, there wouldn't be anything under here, but so it's showing that there's site 1, and site 1 is made up of lots and lots of different parcels. So I can look at each one of these. It's a little hard to see here, but I can bring these up. So each individual parcel, so this is parcel 134. I could hit that, and you can see that parcel. So it's a representation of the boundaries of that parcel. Okay, so certain objects, you can get a preview down here. This is a preview toggle, but there's some that will quickly show you what objects are stored underneath that. What's kind of nice in here is that it'll also show you the area perimeter and what type, some additional information. I can also take any of the objects over here in the prospector menu and bring up properties. And depending on what type of object it is, it'll have different property layers, and we'll be working with this quite a lot. But as you tab through, you'll find different information about that object. And so one thing I do want to point out This drawing does happen to be in metric, so even though like I said, we were in Civil 3D Imperial, the drawing itself was in metric. But anyway, it gives the state plane coordinates, the northing and the easting, and then it talks about all the bearings that make up the properties. This is the legal description, the perimeter and the area. So I can find out additional information about any of these lots. I'm going to close up the site and kind of go back to the surfaces where we had existing ground. I'm going to bring up the surface properties of the existing ground, because we're going to be changing this quite a lot and working with surfaces in the next lab. So surface styles. So we talked about in class the triangular irregular networks, or the TIN networks, and it was a way of sort of efficiently storing a lot of three-dimensional information that represents the ground surface, or the either the proposed ground or the existing ground. But I'm going to change this to contours and triangles, and so you can actually see the tin that makes up this existing ground. And so each one of these are triangles, and so we're just doing straight line interpolation. So any point or vertex of the triangle is a place where we have information. So either we have it from a contour, or we have it from survey points where they did a reading at that particular location. So, and then we just triangulate or interpolate between each of these points. Knowing, like being able to look at a tin is one way of knowing where we sort of have higher confidence about our information. So in this case, you can see if you have high density of tin lines, it means that it's interpolating over relatively short distances, and out here, right, so it's interpolating over long distances. So, you know, there could be a big hole or a mountain or something that we didn't see, and it would just straight line interpolate between the elevation here and the elevation there, and so we might have less confidence if we were draining or designing like some sort of drainage structure out on the fringes. So it's good to know what the tin looks like, so that you can kind of tell, gives you confidence about your survey data. But you can also change to contours. So the way Civil 3D, it talks about design contours are usually bold, and background contours, or like existing contours, are usually sort of gray. You can see I'm going to change them to 1 meter and 5 meter. I'm going to hit escape because I have this actually selected. That's why it looked so bold. But it's saying that the darker lines are every 5 meters, and then the lesser contour lines are every 1 meter. And then I can change the way my contours look just by changing my surface properties. So just to show like what the design ones, these are just bolder in color and in thickness. Okay, I'm going to zoom out and kind of pan over and get to the beginning of my station. So in class, we're just about to start. We talked about linear referencing systems, or stationing. You may remember that when I have 3 digits to the right of the plus sign, it means I'm in meters. If this were in feet units, it would be 0 plus 0, 0. I would only have 2 units, or two numbers between the plus sign and the decimal. So, but we saw earlier that this was in metric. But anyway, this is the center line of the road. The road design actually begins here, but the stationing begins out in the center line of an existing road that's not part of this project. But I'm going to hit this and select the center line. A couple of things happen there. This is one of those things where there's a context-sensitive ribbon. So as soon as I hit this, I get information about the alignment. So this alignment ribbon is something, if you want to start working with define roadway alignments, this is one of those things that can be frustrating because you can't figure out where that ribbon went, but you just have to select that first. What we want to look at is the geometry editor, because I want to show you one additional menu area. So in this case, this is an editor that would let me see what's going on with the geometry of the center line. So it brings up another toolbar. And in here, I want to bring up this grid view. And I always think that it could be called panorama window, because you'll see what happens when I bring this up. It brings up this panorama window, which is just another view of, oh, sorry, pick this up, of the center line. So it shows how the center line is defined. And so we're going to be doing a lot of this starting with, I think, notes 8 in the lecture class, but we'll see that this alignment is made up of tangent sections, so defined by 2 points, no radius, meaning it's just a line, and then curves. So I have a straight tangent section, a curve, tangent, curve, tangent. So there are 5 pieces to this alignment of First Street. So starting at station 0 plus 0, 0, 0, and going 483 meters later, the alignment ends. And then I have some information. Whenever it's curves, I have some additional information about this. But this panorama window we're going to be doing a lot of setting design parameters in it. And so it's important to remember how to get there, which is kind of a sort of convoluted version of steps. But first I have to select an alignment. I have to go to the geometry editor. That brings up this toolbar and then this grid view. So in subsequent labs, we'll be talking about either the panorama window or the grid view. But just remember that that's how you get to that step. Okay, so I'll close this, and we talked about zooming using the wheel. Another one that you often want to use is Zoom Extents, which I tend to just use, type in the command line ZE, but there's also Zoom Extents out here. And this just takes it to your maximum extent of your drawing. Okay, so we haven't done anything with this menu down at the bottom. A couple of things, or the most important one is what's called object snapping. So if I wanted to, let me bring up something where I can kind of zoom into one of the parcels. So object snapping is when you want to kind of use precision with where you're drawing or clicking. So this object snap icon down here is this blue square with the little green dot, and when it's turned on it's blue, and if I turn it off it's white. We haven't drawn any lines yet, but I wanted to sort of show a couple of things. So I have a line here. I have object snapping is off, it's blue or white. As I hover over, nothing really happens. And so if I wanted to draw another line, I could try to approximate and zoom way in and get close, but I'm never going to be exactly right on unless I use object snapping. So when my O snaps are on, if I hover near an object, I can start to get different sort of green squares or green objects from it. And what this is doing is you can see how the tooltip it comes up with the word endpoint. A square is an endpoint. If I'm near the middle, you'll see it'll start to say midpoint, and it shows me a triangle. If I go over in here, I can see the sort of the same thing. I got endpoints. I can do midpoints. If it was something that had a radius, it would draw. It would, as I hovered nearer to the center of it, that would be highlighted. I can also do like perpendicular. That's another one that I can start to use. So if I wanted to draw another line, and I could go from some point out in space, and I wanted to snap to the end point, I wanted to snap to the middle, and you can see there I finally got perpendicular. So it kind of has a hierarchy of it. Sometimes it can be difficult, like between the midpoint and the perpendicular. In these cases, they're quite close. I can, in the middle of my command, turn off the perpendicular, and so then I would it would only show the midpoint. So changing what types of OSNAPs it's using is just done through here, and like I said, you can do that in the middle of a command, but just you'll get pretty familiar with what these ones do. But you can see that it automatically, as soon as it's selecting something, it's going, even if I'm not on the midpoint, see how it snaps to the midpoint. So the last thing we're going to cover before we actually start drawing objects is the viewport. So over here in the view menu, it defaults typically to just one viewport, but I can change it to kind of different configurations. So I'll show two horizontal, and so in this case I have a drawing up here, and if I make this one active, I can bring this one up. So I might want to have different views. I might want to be able to see the profile and this one. So these are the same drawings, they're just kind of being able to zoom into multiple places in your drawing at the same time. For the most part, we'll be working in just a single viewport, but kind of point out, because sometimes when you're designing it's helpful to do that, but more often than not it's that somehow you've gotten into a multiple viewport situation and you want to remember how to get back out of it. So it's just view, and then you can default to a single one, and it brings that view back. Okay, so now we're kind of done navigating the various sort of areas and command lines and toolbars in Civil 3D, and we're actually going to finally start drawing things. I'm going to go ahead and hit this plus. This just brings up a blank drawing so that I'm kind of given a blank canvas to work on. And the very first thing we're going to do is just look at drawing lines. So you might have seen, because I was drawing lines earlier, I typed L. That brings it up. I could also type line. Oh, I'm in the middle of a command. Line, that brings it up as well. And then the other way is on the home, under draw, you'll see lines. So if I just want to draw a simple line, first location, first place, second, and it's a running command, it'll keep going until I hit escape. I guess the next useful command is erasing things. So if I go ahead and create a crossing. What's interesting about the way Civil 3D or AutoCAD in general works is there's two different ways. If I go to the right, it only selects objects that are fully enclosed, and then if I go to the left, I get the green kind of lasso, and it's anything a crossing. So there's two different ways of selecting. So I can select and hit delete. I can also hit an E for erase command, and then I can select individual objects or whatnot. So anyway, so if I have a line, so a couple things will show up when I start. Is it says specify the first point. It could be asking for coordinates, and so as you see as I'm moving around, it's giving me different coordinates. Or I can just select by selecting a random point, or if I had another object in there, I could select and use those OSNAPs. And so in the middle of the command, I could set, it's going to give me different distances, right? And so instead of, I could force it, right, to be 64 feet. Right? So you can see how it's going to tell me if I were to click, if I were to left click at any point, how long it would be, but it's highlighted in blue, so it's telling me that I can actually override it, right? And I can, finish up and delete. Right. Other ways that I can create lines, if I go up to the line command, or the line icon in the home menu, I can hit that down arrow, and I can see there's lots of different ways. Instead of just being able to select points, I can actually enter them in by northing and easting, latitude and longitude. I can also create lines by bearings. Lots of different choices. So there's two types of line commands that I want to show you, just to kind of tie back with earlier parts in the class. And the first one is to create a line by northing and easting. So as you remember from class, the northing is essentially your y coordinate and easting is your x coordinate. So I'm going to go ahead and select a line. I'm going to, using that table that's in the handout, I want to start at a northing of 100 and an easting of 100. One of the things that's kind of confusing is it doesn't look like anything's happened, right? But we're going to go ahead and put all the coordinates in and then kind of illustrate a couple things. So 127, 522, 348, 438. So it's showing you how it's switching back and forth between northern and eastings. You'll also see a feature that it defaults to whatever you used the last time. So you can see that the northing defaulted to the previous one, which can be helpful. But the big thing here is that kind of getting used to the way you can input commands in the middle of a particular command or input values. 942. 291, 430, 57.490, and then I'm going to go back to 100 and 100. And now I'm done. I'm going to hit enter. Or escape, sorry, not enter. So I'm using my wheel. I'm going to zoom and then kind of pan. So I was using the line by northing and easting. It went through, and I went all the way back around my four-sided polygon, so I put the 5 sets of coordinates in. I hit escape, and now I'm just in a normal line command, so I could keep going, but in this case I'm going to hit escape again. And so this is kind of a common thing in these kind of AutoCAD commands, that the first time you escape, it kind of takes you from an advanced feature to the basic feature, and so sometimes you're escaping multiple times. You can't over escape, so sometimes I just hit escape a lot of times until I'm done, but it does a lot of running commands. So when we were drawing this, we didn't see what was going on because it was off of the screen. Where we were at in our coordinates was not in the view area. Anyway, so it didn't look like anything was happening. That's another thing, is that when you put things in by coordinates, you have to look to see where you are. So if you're going to be using or concerned about coordinates or using some of the features that require inputting of coordinates, down here in the lower right-hand side, you can change what is showing up on your bottom menu. So far we've really only used this OSNAP command, but I can turn on coordinates, and now I can see as I move around, I have no Z coordinates. Everything is just being done on X and Y, and you can see as I hover over them, you'll get that. You'll get the northern and eastern coordinates for wherever your cursor currently is. So that can be helpful, because if you're drawing off into a different part of your drawing space than you're currently zoomed into, it can be a little confusing about what's going on. Okay, so the other line command I wanted to show is line by bearing. So we're just going to pick kind of an arbitrary point, and you'll see that it brings up a little survey-like instrument in yellow. And so bearings, obviously we have to define the quadrant and then the angle. So first it wants to know which quadrant you're in. So we're going to be trying to draw a line in the northeast quadrant. So I could either type in 1, you can see that it goes from 1 to 2, 3 is southwest, 4 is northwest, or I can just click anywhere in this point. So kind of two ways. I could put a 1 in, or I could just click. Both of them do the same thing. So then it's specifying the bearing. One of the things that's strange about Civil 3D is that in most cases it's already, the way it defaults to is it expects you to be in degrees, minutes, and seconds. So how you input that in, so we want to put in 45 degrees, 30 minutes, and 30.5 seconds. So I put in 45, so my integer, or my values to the left of the decimal places are my degrees. and I'm going to put a decimal place, and it expects it to be in degrees, minutes, and seconds. So I don't convert it, since so the next two after the decimal place, the next two values are minutes, and then anything after that, it would expect it to be in seconds, and if I had decimal seconds, I would just put it in again. So this is a little bit kind of different, certainly different than what probably you're putting in into your calculator. So that reads as 45 degrees, 30 minutes, and 30.5 seconds. If I had a value, my bearing was in decimal degrees, I would have to convert it to degrees, minutes, and seconds and put it in here. If you had a lot of them, then I'd type in units and kind of override the default, but in general it's just going to want degrees, minutes, and seconds in that format, which is a little bit strange. So then the last part is it wants a distance. I'm going to put it at 100 feet, right? And so back here is the 100 degrees at the 45 degrees, 30 minutes. And then it's a running command, and I could keep going. And so I could specify the next quadrant and the next bearing, and it would be a running command. If I hit escape once, it changes it back to my just generic line command. And if I hit escape twice, it takes me out of the line commands altogether. The next thing we're going to do is look at creating curves instead of lines. But to do this, I actually want to first start with a couple of lines. So a two-segment line. I'm going to make these relatively short. I can double click on it and it will tell me they're about 134 feet long. They're 138 feet long. Anyway, I want to create a curve. So if I go up to my home menu in the draw panel, we've been using the line command. This one is an arc command and this one is a curve command. And really the difference is that curve commands maintain tangency. So when we're talking about roadway design or railroad design or pretty much anything from a civil engineering design standpoint, we almost always want curves over arcs. Where if we look at these, I can fit an arc that goes through particular points, but it's not necessarily tangent to anything. Where these ones, I'm maintaining the tangency of some features. So that's why I needed to start with two lines. So I'm going to create a curve by two lines. It's going to ask me for the first tangent and the second tangent, and then it's going to bring up some options that I can define my curve by. We're going to be talking about this in the lecture part of class, what all these pieces of a simple horizontal curve are, but I think you guys all know what a radius is, and that's probably the most common way that we define what a curve is anyway. But if I wanted to change it, I would just go in here and select it. I could hit chord, and it would ask for the chord distance. I could either put it in as a value, or I could select the chord. But I just wanted to show that. I really want to create it with a radius. So if I select it and I select it, the radius, and now I can just put in the 50 feet. Oh, sorry, radius. I had to verify that I wanted radius first. That's what it was asking. And then now it's saying what is the distance of my radius, and you'll see that I have 50 feet. Now if I just hit enter so I can go back to anytime you hit enter, it defaults back to the previous command. If I were to do this and I were trying to select radius and put 5,000 feet, it would actually give me the radius is too large. So sometimes you're trying to fit a radius in that cannot fit. It means that the point of curvature where this curve begins is beyond where the tangent is actually drawn. So that's a common error that comes up. So in this case, you can see it creates a curve that's tangent to this, but it maintains the tangent lines. I could hit TR for trim, and I could try to trim these back if I wanted to get rid of the curve. But in most cases, it defaults to keeping those. I also want to point out if I hit U, for undo. So I can kind of go back and bring those in. So hitting the undo command, the same thing is up here. I can hit an undo command. It reverses. Most things can be undone. So, and there's also up here a redo. So undo and redo up at the top is pretty useful. The last command that we're going to do for this first lab is just a hatch command. So go ahead and draw a polygon of however many sides you want. Make sure it's closed. And up on that draw panel, so we've been using line and curve, and over here, if I hover over it, you'll see it says hatch command. So I'm going to go ahead and select that. It actually is a feature that has a lot of attributes to it, or a lot of things that you can specify. So once I hit that hatch command, I get a whole nother ribbon for it. In most, it's always going to default to what they call pick an internal point. And if you have a really, completely closed polygon, it will, if I pick a piece internal to it, it'll automatically default to that. I can also, instead of I could do pick points from picking different objects, I can also select boundary objects. But this smart feature of picking the internal point, if it is recognizing what it is you're trying to hatch, is pretty convenient. So if I pick that internal point, it creates a hatch object. So it's its own object. So if I select it, it's kind of selected in there, and delete, it's going to delete all at once. I'm going to redo so you can, oh, that didn't, that is not something I can redo apparently. So I can pick this point, I can change some of my patterns. In this case, if I select a hatch, I can go in here and start changing some of the features. So what I did there was I hatched it as this diagonal line, but it looked solid. If I were to go back, I might have to zoom in pretty far, but it had to do with the scale of it. So if I went in here, I changed it, instead of changing it to 100, maybe I'll change it to 25, change it to 100. I can do the scale of it. I can change the pattern once it's selected, and I can also change the angle of it. So, but if you go through and look through the library, you can see a lot of different kind of common features used in civil engineering. So hatches are used a lot to sort of define areas. So maybe you're trying to explain on a given site, like where your grassy areas or your wetlands, where your hard surfaces are, or if you're trying to show a building cross-section, what some of the materials, what part is, brick or concrete, and whatnot. So you can kind of go through and see lots of different patterns. Similar to layers, the type of hatching is something that when you're creating plans for particular agencies, they're going to have a defined sort of manual for what those look like. So that's all for the demonstration. So what you're going to do for your assignment part of the lab is you're going to open a blank drawing. You can just do that by hitting the plus sign and going ahead and naming it. You can look at the handout for the naming convention. And you're just going to do a few things, first by drawing a line using the northing and easting, so going back and using the line by northing and easting. And you're going to put in the two coordinates, the north coordinate and the east coordinate. Now recognize that you're, with a blank drawing, you're going to be nowhere near where those are. So the first thing you just do is put in that northing and easting, and you're going to want to create a line that's about 100 feet north and 100 feet east. So all you're doing is adding 100 to that north coordinate and that east coordinate, and so you're going to get a line in there, and then go ahead and hit zoom extents, and so that way you can actually find where you are on the drawing, and then that just gets you so that you have a drawing in the appropriate coordinate location, and then you can go through and snap to the end of that line, that first coordinate, or the lower left end of the line, and then start doing a drawing by bearing and go around. You're defining a parcel that goes all the way around, and you will close at the beginning when you draw your last bearing. Now if you were to zoom in really, really close, you'll actually find that there's a little bit of, because of the number of decimal places, that the bearing distance, it won't close exactly, but as long as you're sort of zoomed out a little bit, it'll look like you're closed. That's how you'll know that you've done the bearings, lines by bearings correctly. The other piece of it is you're going to just be creating a series of tangents and two curves. This will actually later become an in-class problem, and you'll see it again, but this is just making sure that you can draw particular tangents. It represents the center line of a road and some horizontal curves on that road. So you'll just have those two pretty simple things. Shouldn't really take more than maybe 15 minutes to do, and then you're going to save it as just back to your own folder, but you can upload the DWG or the drawing file. You don't have to convert it to a PDF or look at anything like that, and just upload it to Blackboard and you're done. And starting with the next lab, we'll kind of dig into a little bit more, but just wanted to provide a brief introduction to Civil 3D for those of you who might not have had the opportunity to use it in previous jobs. So, thanks.